Okay, we're going to go ahead and do an example of solving a three-variable system in three equations. Notice that anytime we do a system, two variables, two equations, three variables, three equations, the number of variables has to match the number of equations that we have. That's not by accident. It has to be that way. So the first thing that we're going to do is we have to take two pairs of our three-variable equations and use elimination to condense them down into two variable equations. The first thing I always do is label my three equations so that I'm able to reference them through my work. That way if I make a mistake, it's easy for me to go back and find where that mistake was, and it also helps my teacher to grade my work so that I can get the most partial credit as possible. It's easier for her to follow along. So the first thing that we have to do is figure out which variable we are going to eliminate. Now, I am going to eliminate y. I notice right off the bat that this is a y by itself, and that all I'm going to have to do is multiply equation c by positive 4. Then I can put it together with a. I'll eliminate the y. And then I can put it together with b, and I could eliminate the y. Now, you may look at this and think that z is easier because all you have to do is multiply by -1 to get the z's to cancel. That would be okay too. It really doesn't matter what your first step is as long as you set it up following all the rules using elimination. I already said I'm going to eliminate y, so I'm going to go ahead and do it that way. So I'm going to take equations a and c and put them together. A, I'm not going to do anything to, but c, I'm going to multiply by 4. Okay. Now, we'll go ahead and just recopy A exactly as we see it. 3x minus 4y plus z equals -5. But equation C, we have to multiply everything by 4 before we do that. This is a really easy one to multiply because all of the coefficients are 1. So I now have 4x plus 4y plus 4z equals 24. Again, what I just did was multiply this by 4 and this by 4 and this by 4 and this by 4. All of the terms in equation C. Now that I have done that, we are going to add these two equations together. Because we set it up this way, the y's are going to eliminate. What we have left is 7x plus 5z equals 19. So we now have one equation in two variables. We need to make another one. So we're going to go back to the drawing board. This time I'm going to use b with 4c. So just like before, I'm going to recopy equation b. 6x minus 4y plus z equals 1. And I've actually, remember up here, I've already done 4c, so I'm just going to recopy what I already did there. 4x plus 4y plus 4z equals 24. Again, if we set it up correctly, our y's should eliminate, and we can see that they will. So we now have 10x plus 5z equals 25. So let's take a look at what we just did here. All we did was make pairs of equations. The first pair that I chose to make was A and C. The second pair that I chose to make was B and 4C. Okay. The reason I multiplied by 4 is again because I'm trying to get the y's to eliminate. We're always trying to make opposites when we're doing elimination. Now that we have those two equations, our next step is to take those two and put them together in a new system. This system is only going to have two variables, and we have a method for solving those. So I'm going to recopy them. 7x plus 5z equals 19, and 10x plus 5z equals 25. Now I have to use elimination again here. This one looks like it's set up really nicely to do elimination because they are both a 5z. I need them to be opposites, however, so I'm going to go ahead and multiply this top one by -1. That gives me negative 7x minus 5z equals negative 19. And now I can add those together. My z's cancel just like they should, and we get 3x equals 6. Dividing by 3 on both sides tells us that x is going to be equal to 2. Now that's our first one, okay? If you look at what we did here, we just went from 3 equations and 3 variables down to 2 equations and 2 variables, and now I'm down to 1 variable, and I know what it is, 3, 2, 1. When we do the substitution step to figure out what the other 2 variables are, we're going to work backwards from 1 into 2 into 3. So since I know that x is equal to 2, when I substitute here, I'm going to take x equals 2 and I have to put it back into one of these 2 equations. Doesn't matter which one, but it has to go into one of those. If I plug it into one of the originals, I'm still going to have 2 variables and I won't be able to solve it. So we can say 7x, so that would be 7 times 2, I'm using the top equation here, plus 5z equals 19. So that gives me 14 plus 5z equals 19. Subtracting 14 from each side gives me 5z equals 5. And when I divide by 5, we see that z is equal to 1. We are almost there. Now that we know what 2 of them are, we're going to go back to 3 variables. We're going to take 2 for x, 1 for z, and we're going to come back and put it into one of these. It does not matter which. I'm going to put it in the last one because the variables are nice and simple there. So I have x, which is 2, plus y, which we don't know, plus 1, which is z, and that equals 6. Well, this is y plus 3. And when I subtract on both sides, I get y equals 3. Remember that our solution is an ordered triple, x, y, z, just like an ordered pair x, y. So we're going to write this as 2, 3, 1. And that's your final answer.